All right, welcome again to Hybrid Account. We are proceeding with the topic correlation and regression analysis. And today we're just going to take a look at the way of checking for evidence of correlation. You know, when there is said to be a correlation between variables, if you are business-wise, actually, you could make use of one variable to get the better or the best of the other, right? Like let's say you know that if you produce more let's say maybe let's presume maybe you are comparing advertisement against revenue. So if you find out that advertisement and revenue are very correlated and maybe in a positive manner, I could say that, oh, let me increase advertisement as much as I can, expecting to earn more revenue. Of course, this wouldn't be infinite, right? Advertisement usually has its end, but actually it would give you an initiative to start dealing and finding out ways on how to make advertisement better and better so that actually you can recoup much more rewards, right? Okay, so in view of that, let's go ahead and take a look at how to check evidence of correlation so that you can decide to be strict on your variables. All right. Now, to check the evidence of correlation, there are some terms that you need to know before going anywhere. First of all, we have something called standard error, right? Standard error of the coefficient of correlation, it is used for ascertaining the probable error of the coefficient of correlation. Don't worry, our main concern is on the probable error, not the standard error, right? Simply speaking, the standard error is obtained this way. You take 1 minus the square of the correlation coefficient, and then you divide by the square root of the sample size, right? So what is the probable error now? The probable error is what would give us something very, very well. You know, for example, when you have a population, it's normal that you won't use the whole population. You would just take a sample from the population to determine your correlation coefficient, right? Yeah. So the correlation coefficient determined using a sample may not very well reflect the population because a sample may not be representative of its population, although it is expected to be that way for it to be perfect, right? Okay, so what is the probable error now? The probable error is the value by which the sample correlation of the sample, not the population, is the value by which the sample correlation or correlation coefficient is reduced and increased. That means plus or minus to obtain the lower and upper limits to make a sample interval within which the true population correlation coefficient is expected to lie. Did you get that one? Or maybe I think we need to make more explanations here, right? Yeah, something like that. What I do mean is presume that you have the population. Let's say you have the population of 200 items, but maybe you have taken the sample of only 20 items. All right. Now, you know, it's difficult to use all the items of the population to obtain the correlation coefficient. So you would say that, oh, let me use this sample of 20, and I would expect to obtain the correlation coefficient of the population using this sample. All right. Now, let's presume that the actual correlation coefficient of the population is, let's say, 0.8. But since we use the sample, let's say that the correlation coefficient using the sample was 0.75. You know, I hope you can see this now. So it showed that the sample can give a correlation coefficient that is not exactly equal to what you would have obtained had you used the entire items in the population, right? Yes. So in view of that, we try to make a certain interval in such a way that this 0.8 should be within that interval. How do we do that? To obtain the interval now, we say 0.75 correlation coefficient of the sample plus or minus probable what? Probable error. For example, let's presume that maybe our probable error equals to 0.15. I'm just presuming here, right? So if you do that, you would say that, oh, my interval, how much would it be now? 0.75 minus 0.15, 0.75 minus 0.15 up to 0.75, 0.75 plus 0.15, and this is going to give you 0.6 up to 0.9. Do you see this now? Right now, I have the range, I have the interval using this sample within which the correlation coefficient of the actual population could lie. 0.8 is actually between 0.6 and 0.9, right? Yeah, so that's what I meant by the probable error. So it's something that can be added or subtracted in order to arrive at the figure just stated, right? Yeah. So it's just something like that. All right. So how do we determine the probable error? You just take 0.6745. Statisticians did that. Multiply by the standard error. So simply speaking, the probable error is used for determining the reliability of the value of R so far as it depends on the condition of random sampling, actually. So after determining this probable error now, the last step that we have to follow in order to reach our conclusion. So if the correlation coefficient, the magnitude, the absolute value, correlation coefficient can be positive or negative. So we just take a look, we just consider the magnitude, ignore the negative sign. If the magnitude of the correlation coefficient is less than 6 times the probable error, we say that, oh, if you take the probable error, you multiply it by 6 and it exceeds the correlation coefficient, or we say that the correlation coefficient is low. So the value of correlation coefficient is not significant. You cannot expect, let's say you are comparing advertisement and revenue, you cannot expect to alter advertisement to reliably get more revenue, to increase advertisement to reliably get more revenue. So we say the correlation coefficient is not significant. And so we say there is no evidence of correlation, else there is evidence of correlation. So in case it is the opposite, we say there is evidence of correlation. All right, let's take a look at an example here. In a school, there are 950 students, 100 students were randomly selected. And the correlation between their marks in quantitative techniques, one subject, and business management was derived as negative 0.35, right? But now required, is there an evidence of correlation or not? All right, we go to the solution. All right, let's take our data. We are given the correlation coefficient as negative 0.35. The sample size n is 100. We have the population size, but also have the sample size. So we deal with the sample here. Now, we say that there is no evidence of correlation if the magnitude of the correlation coefficient is less than 6 times the probable error. But we know that the probable error equals to 0.675 times the standard error. What is the standard error again? Standard error equals to 1 minus the square of the correlation coefficient over square root of the sample size. So you just substitute your data here. Correlation coefficient was negative 0.35. You do square it. You take 1 minus that figure, and then you divide by the square root of the sample size n, which was 100. And then you arrive at this figure. I hope you have the calculator with you aside, so as to make matters much simpler. All right, now you can have a probable error is 0.6745 times standard error, which if you multiply, you would end up with this figure here, 0.059266, right? Okay, so after having that probable error now, we go and make this comparison. We compare error in magnitude in absolute value against 6 times the probable error. All right, so we ask ourselves, is magnitude of error less than 6 PE? Okay, error was negative 0.35. This one, 6 times the probable error. This one, 0.059266. All right, If you take the absolute signs here, this one would be positive. So it would be 0.35 positive less than 0.3556. Yes, 0.35 is less than this figure. And since it is less, we say that there is no evidence of correlation. So that's all about checking evidence of correlation. And actually, if you haven't subscribed, you can do that for regular updates. Thank you very much, and until next time.